Hello, this video covers section 2.1, organizing data. Data collected in the original form is called raw data. A frequency distribution is the organization of raw data in table form using classes and frequencies. Okay, so I've added some things to this table. So first, this is called a frequency distribution table. And we have the class limits. In each of these categories, we can call a class A. And each value above is placed into a class. So for example, if you look at this, that would mean there are 3 values between 36 and 44. The frequency, of course, would just be 3. And if you look above, you can see that we had 3 values in between 36 and 44. So you can see I have 38 twice, and then I also have 44 right here. And so that's how we would get the tally mark of 3. All right. And then notice the total number of values is listed right here. And that would also be all of these numbers added together should equal that total number. And then just remember that the frequency, of course, is the number of values in each class. Now, there are 2 types of frequency distributions that are most often used, and that is categorical and grouped frequency distributions. Nominal or ordinal level data that can be placed into categories is organized in categorical frequency distributions. Here is an example of 25 Army inductees that were given blood tests to determine their blood type. So we can actually construct a frequency distribution for this data. And let's see. So you can see we've got the different blood types right here, and that would be 25 of them. And we are going to go ahead and construct this table here. And notice that since the data is categorical, the discrete classes can be used. And of course, that would be based on blood type. All right. So the classes would be blood type A, blood type B, blood type O, and then blood type AB. And then we would use the tally to help us to determine how many there are. Okay, so for A, I have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then that frequency would be 5. And what we'll do is we'll do this percent last. Let's go ahead and do our tallies first. Okay, so then for B, I have 1, 2, 3, 4, 5, 6, 7. Okay. And then for O, we have 1, 2, 3, 4, 5, 6, 7, 8. 9. Almost missed one. All right, so we have 9. And then for AB, we have 1, 2, 3, 4. 1, 2, 3, 4. Okay. All right, so we've got our tally, we've got our frequency, and now we're going to actually do the percent. So the percent is not bad. We just have to do basically the frequency over the number of values, and that multiply that by 100 is going to give us our percent. Okay, so the number, n is the total number of values. Of course, in this case, n is equal to 25 because we have 25 Army inductees with 25 blood types that were listed for each person, right? So this first one would be 5 over 25, and then I would take that and multiply it by 100, and that will give me the percent, which would be 20%. So I'm just doing F over N, and notice that N is constant. It's always going to be 25 for each of these. The F is the frequency, which I'm getting from the work I've already done. All right, so the next one would be 7 over 25 times 100, which would be 28%. And so you can use a calculator for sure. And then 9 over 25 times 100, which would be 36%. And then 4 over 25 times 100, which would be 16%. All right, so that is just what our frequency table looks like. And now we're going to go ahead and move into this next part, which is grouped frequency distributions. So group frequency distributions are used when the range of the data is large. The smallest and largest possible data values in a class are the lower and upper class limits. Class boundaries separate the classes. All right, so this is just an example of what that would look like. So you can see we have class limits here in this table. We've got class limits and we have class boundaries. And if you look at these numbers closely, you might notice that this number here correlates to these two numbers. I would basically add those together and divide by 2. And then the same would be true from 71 to 72. If I added that together and divided by 2, I would get 71.5 and so on. We're going to talk about how to do this in an example very soon. So to find a class boundary, average the upper class limit of one class and the lower class limit of the next class, okay? And that's basically what I was just talking about. So this 64 would be considered the upper class limit, and then the next class, 65, is the lower. And so to do the average, we would just do 64 plus 65, and we would divide that by 2, and we would get 64.5, which would help us with our boundary. All right. The rule is the class limits should have the same decimal place value as the data, but the class boundaries should have one additional place value and end in a 5. So you'll notice that for the class limits, we should have the same decimal place value as the data, but the class boundaries should have one additional place and end in 5. So you can see all of these are ending in 5. All right, and that's because we take the average and divide by 2, we end up with 0.5. Now the class width for a class in a frequency distribution is found by subtracting the lower upper class limit of one class from the lower upper class limit of the next class. And the class width can be calculated by subtracting successive lower class limits or boundaries, successive upper class limit or boundaries, or upper and lower class boundaries. Okay, so for example, the width could be calculated. I'm going to do it the easiest way I know how. We could just do the successive lower class limits or boundaries, which would be 100 minus 93, which would give me 7. Or I could do the upper successive. So this would be the upper 106 minus 99, which would give me 7. Or I could do 106.5 minus 99.5, which would also give me 7. Regardless, I end up with 7, all right? And then the class midpoint can be calculated by averaging upper and lower class limits or boundaries. For example, to find the class midpoint, I can do the lower limit plus the upper limit and divide by 2. And that would give me the midpoint. All right, so that's a formula for the class midpoint. And we're going to be doing an example like that in just a moment. All right, let's keep going. All right, here are some rules for classes and grouped frequency distribution. There should be 5 to 20 classes. The class width should be an odd number. This ensures that the midpoint of each class has the same place value as the data. The midpoint is the numeric location of the center of the class. You will use the midpoint when graphing histograms in section 2.2. If class width is an even number, then the midpoint will be in tenths, and the classes must be mutually exclusive. That means there are no overlapping class limits, so the data cannot be placed in 2 classes. The classes must be continuous. Even if there are no values in the class must be included in the frequency distribution. The only exception occurs when the class with a 0 frequency is the first or last class. The classes must be exhaustive. There should be enough classes to accommodate the data. The classes must be equal in width except in open-ended distributions. This avoids a distorted view of the data. Okay, so you can see that we've got this. Let me zoom in a little bit. So this is an example of like breaking the rules, right? Because this goes from 10 to 20, 20 to 30, 30 to 40, 40 to 50, that's a problem. Let's pretend you're 20, then you would fall into two categories, which is not good. All right, so we always want to have the limits to where you're only able to be in one category. For example, if I'm 20, I would fall into this category. If I'm 42, I would fall into that category, etc. And that would be considered like overlapping. All right. Okay, so let me talk briefly about open-ended. What would be an example of open-ended? All right, so an example, so here is an example of open-ended. That would be like if we had less than 19, and then we did 19 through 23, 24 through 28, etc. This would be considered open-ended because less than 19 would just be anybody that was less than 19, which would include a variety of number of ages. All right, so that's what they mean by open-ended, that the classes must be equal except in open-ended distributions, and that's what that means. All right, let's move into the procedure of constructing a grouped frequency distribution. So let's go ahead and move to that. So we're going to construct this, and I'm going to kind of label this. So we have step one, which is actually kind of like a whole lot. So we're going to say that A is find the highest and lowest values. B is going to be the range. So the range is just the highest value minus the lowest value. So the highest minus the lowest. Select the number of classes desired and find the width by dividing the range by the number of classes and rounding up. And then select a starting point, usually the lowest value or any convenient number less than the lowest value. Add the width to get the lower limits, and then we will find the upper class limits and we'll find the boundaries. Okay, and then of course we'll tally the data and then do the numerical frequencies, which is kind of like the easier part. All right, so the following data represent the record high temperatures for each of the 50 states. Construct a grouped frequency distribution for the data using 7 classes. Okay, so we're going to use 7 classes and we're constructing a grouped frequency distribution. So first, we need to find the lowest value, and we find that to be 100. We need to find the highest value, which is 134. Then I can do 134 minus 100, which is 34. And then that is my range. To find the width, I'm going to do the range divided by the number of classes. Now remember, they gave us 7, and that's what we're going to use because they're telling us to use that. Okay, so they could say 8 classes, they could say 5 classes, but they're telling us to do 7. So I do 34 divided by 7. I get approximately 4.9. We do round that up if it does not produce a whole number. So that means that our width is going to be 5. All right, so we're going to select a starting point. I usually use the lowest value, and this is going to be the first lower class limit. So let's go ahead and work on that first. All right, so the way I'm going to find the class limits is I'm going to start with 100, and then remember our width is 5, and that width is going to help us with our class limits, the lower limit. All right, so what I'll do is I'll do 100 plus 5, which is 105. And then 105 plus 5 would be 110. And then 110 plus 5 is 115, which is already marked. 115 plus 5 is 120, which is already marked. And then 120 plus 5 is 125, which would go here. All right, so that's going to help me with the lower class limit. All right. Okay, so the first upper class limit is 1 less than the next lower class limit. The subsequent upper class limits are found by adding the width to the previous upper class limits. Okay, so this is not so bad. So what happens is I'm going to go from 100 to 104. Notice that is 1 less than 105, right? And then I can do one less than 110, which would be 109. Or I can simply do 104 plus 5 to get 109. And then I can just keep adding 5 to these numbers. Okay, so if I add 5 to 109, I get 114, which is, of course, one less than 115. If I add 5 to 114, I get 119. And then so it's just plus 5, and so on. So that'd be 124. Plus 5 is 129. And then plus 5 is 134. Alrighty, okay, so that's how I find my class limits. Okay, so that's pretty easy, right? Not too bad. So now we're going to talk about how to do the class boundaries, okay? So to do the class boundaries, we are going to take our upper class limit and then the subsequent next class limit, which would be the lower, we're going to find the average of that. Well, that would be 104 plus 105 divided by 2, which would give me 104.5. Okay, and that would represent the upper class boundary. So let me do this over here. So 104.5. Now for 100, if you remember by the definition, we just do 0.5 less. So that would be 99.5. Okay, so from our starting, we just do 0.5 less. So the class boundary is midway between an upper class limit and a subsequent lower class limit. 104, 104.5, and 105. Recall our technique from chapter 1 and use it. Okay, so that's my first one. And then I can do the same thing here. This would be 109 plus 110 divided by 2, which is no surprise, that's 109.5. Now, to get this lower one, I used 104.5. Okay, so one of my numbers I already have. So for each of these, I'm filling in 2 blanks, right? But one of them I have from the previous. So this would be 109.5. And then some people will say, well, it's very obvious that for 115 and 114, it's going to be 114.5 and so on. Then I would have 114.5 to 119.5. I hope that you see there is a good pattern here. Then I start with 119.5, and that would be 124.5. I use 124.5 again here, and then that would take me to 129.5. And then I've got 129.5. So you can see I just want to point out again, the upper becomes the lower, the upper becomes the lower, the upper becomes the lower, and so on. Okay, that should help you. And then I'm going to end at 134.5. So notice I'm 0.5 higher than my last value, and I'm 0.5 lower than my lowest value. All right, cool. We're almost done. Let's go ahead and move on to the tally part. So now we have our class boundaries and our class limits. We can actually start to create the tallies here. And so what we've got is I'm going to look at from 100 to 104, and those are the tallies I'm going to have. So I only have 2 of them. I have 100 and it looks like I have 104. Okay, so I'm just going to kind of mark those off. So that would be 2. So the frequency, of course, would be 2. And I would just do that for each one. So from 105 to 109. And I know that 1, 2, 3, sorry, let me focus. 4, 5, 6. So I'm just finding these values from 105 to 109. 7, 8. I think there's one more. Where is it? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. There's only 8. Okay, cool. So 1, 2, 3, 4, 5, 6, 7, 8. That would be 8. And I just want to point out, I know we don't have any of these values in our actual data, but if we did, like let's say I had 103.5, I would include that in my tallies for that class limit. Okay. All right. So I would keep going here. And so from 109 to 114, I end up with 18. So that would be 5, 10, 15, 18. Okay, so I would imagine that you would cross these out and find these yourself. But I'm just looking, remember, I'm looking for the in between 115 and 19. And there is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then for 120 to 124, there are 7. That would be 7. And then from 125 to 129, there's only 1. And from 130 to 134, there's only 1. That would be 1 and 1. All right. We are doing pretty good. Now, I kind of did that all together. I did the tally and I also did the frequency, of course. So once again, I would just have 2, 8, 18, 13, 7, 1, and 1. All right, and then the last part, so I just want to point out that the total should be 50, right? So the total should be 50. And so if I add all of these numbers together, I should definitely get 50. And then we have another approach that we could do, which is we can include the cumulative frequency. And so we would start with 2, and then cumulative frequency just means how many like total at the time. So for this next one, I would have 2 plus 8, which would give me 10, and then 10, but then I add 18 more, which would be 28. 28 plus 13 would give me 41, and then 41 plus 7 would give me 48. 48 plus 1 is 49, and then 49 plus 1 is 50, and that would be my total of 50. All right. Okay, so I hope this video helps you, and I hope you have a great day. Bye.